Welcome back. Now we are going to solve question number 5. Question is the figure 2 shows a plot of part of the curve with the equation y is equal to cos 2x with x being measured in radians. The point P shown on the figure 2 is the minimum point of the curve. We can see here point P is shown and it's the minimum point of the curve. State the coordinate of the point P. Now for stating the coordinate of P, we have to look at the given equation, which is y is equal to cos 2x. We know that if it is y is equal to cos 2x, so there will be no change in the y values, because if we double the angle or triple the angle, so there will be no change in the y value. And for cosine, the maximum value is 1 and minus 1. So it means I can say this maximum value, this is 1, and this minimum value is minus 1. So between that also, it's better if we count on the number of boxes, because we may need to use it for the later parts. Number of boxes are 1, 2, 3, and 4, so it means each box is 0.25. So y coordinate of the point P, it means is -1. Now we need to get about the x coordinates. For x coordinates, if I can say this is an where x-axis, the curve cut the x-axis. This is the point where the curve cut the x-axis. This is the point where curve cut the x-axis. And here it is. So about the cosine, we know if we have y is equal to cosine x only, so the maximum value is at 0 degree. For y is equal to cosine x, the maximum value is at 0. Then the next maximum value is at 180 degree. Then the next maximum value is for the maximum value is at 0 degree, and if I take measurements in the form of, so cos 0 is 0, cos 90, sorry, let me change it into the mode, or let it be in this mode. I can say it's better if we change it into this format. Sorry, I can say if initially this is the first value where cosine is becoming 0, this cos 2x is 0. So I can say cos 2x equal to 0. From here, if I will find 2x, it will be cos inverse 0. So cos inverse 0, if in degree measures, I want to count, it will be cos inverse 0, which is pi by 2. So pi by 2. It means x will be pi by 4. So this value is pi by 4. Then write it pi by 4. Then take the steps of pi by 4, pi by 4. So another pi by 4, this will be pi by 2. Another pi by 4, if in this one I will add another pi by 4, let's divide it by 2, it will be pi by 4. Then add another pi by 4, that will be pi by 2. Then adding another pi by 4 in this one, it will give me 3 pi by 4. It means this value is 3 pi by 4. Then add another pi by 4 in this value. Adding another pi by 4 will be pi. Adding another pi by 4, that will be 5 pi by 4. Now this one is 5 pi by 4. Adding another pi by 4 is 3 pi by 2. This one is 3 pi by 2. Now adding another pi by 4 will make it 7 pi by 4. I think I'm going mistake. Yes, so it was pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, and then, sorry, just 1 second, 5 pi by 4, and plus another pi by 4, that is 3 pi by 4, 3 pi by 2. Then in 3 pi by 2, another pi by 4, adding another pi by 4 in this one, will make 7 pi by 4. It means this one is 7 pi by 4. Then if it is, if we consider this one, add another pi by 4, it will be 2 pi. Then adding another pi by 4 is 9 pi by 4. Adding another pi by 4, this point will be 5 pi by 2. Adding another pi by 4, this will be 11 pi by 4. And then adding another pi by 4, this is 3 pi. This graph is actually from 0 to 3 pi, we can say. So look at the coordinate of P. Easily we can say this coordinate is pi by 2. So coordinate of P is pi by 2, -1. So next is a copy of the figure 2 called diagram 1 is shown at the top of the next page. Sketch on the diagram the curve y is equal to sin x. Now on this one we have to sketch the curve y is equal to sin x. So if I have to sketch, I know that about these values already. So at different points, if I will, it's better. For example, if this is 0 and on the full graph I have to sketch it. So starting from this one, if this is 0, this is negative pi by 4 and this one is negative pi by 2. So I need to sketch the graph for y is equal to sin of x. So one by one, if I will take the values, it's better using the calculator, will be more accurate. If I will take for sin negative pi by 2, sin negative pi by 2 will give me -1. So it means for this one, if I will take the graph, will start from here. This will be the first point of the graph. Then if I will take for sin of negative pi by 4, sorry, it should be pi by 4 is 0.707. So if I will take 0.707, it will be approximately 0.25, 0.5, 0.75. So almost you can say here. Then next one for sin 0, if I will take sin 0 is 0. So this value will be 0 over here. Another point here. Similarly, if I will take for now the next one, this is pi by 4, as previously we found that already. So sin pi by 4 if I will take. So sin pi by 4 is sin pi by 4. So we'll make sin pi by 4 will be still 0.07. So 0.0707 for this one, 0.5, so 0.75, so approximately here you can say. And then if I will take for pi by 2, sin of pi by 2 will give me, it is sin of pi by 2, that is 1. So this is one maximum value here. And then the next one we know for after pi by 2, if we look for this one, what this was, yes, after is 3 pi by 4. Now check the value of sin 3 pi by 4. If I will try to write for the 3 pi by 4. 3 pi by 4 will be 0.07, which I can write it here, 0.07 for 3 pi by 4. It will be here. Then the next value was for, it's better if I write all these values on which I have to take is pi. Next sin pi. So let's write for the sin pi is 0. So for sin pi it is 0. It means this one is next value is sin pi. Sin pi is here. I think it will be more better if I will draw here and then we'll copy it. Otherwise I need to go back each time. So here it was -1, then it was 0.707, which was approximately here, then 0, then it was 0.7, then 1. Yes. So from here it's better keep drawing the curve along with that. Okay, till this one. Then after that, for 3 pi by 4, found that for 3 pi by 4 it was this value, approximately here you can. And then for pi we just found right now, for pi it was 0. Then check for the next one, which is 5 pi by 4. So if I will take for sine 5 pi by 4, the value for it will give you negative 0.707. So that will be approximately here. And then for 3 pi by 2, if I will check it for 3 pi by 2, the value for 3 pi by 2 be -1. So it will be here until this one is here. Then next one is 7 pi by for 7 pi by 4. If I will try to take for 7 pi by 4, so this value is going to be negative 0.707. So almost you can say here. And then for 2 pi, you know very well that sine 2 pi will be 0. So it's going to be 0 here. Then again, from here it will pass through and will reach to this maximum here. And then from this maximum, it will come down, let's see, for 11 pi by 4. What value will be at sine 11 pi by 4? So make sure it might take a little bit time, but will be more accurate if instead of just simple guess you will do 0.7. So here, and then obviously from here, it will hit to for 3 pi. If I will take sine 3 pi, will be 0. For 3 pi, is going to be 0. So we sketch this curve. Now I will copy this curve from here, so it will become more easy for me to transfer it. Let's say if I copy this sketch, too many values are there, even difficult to copy. But let's try to copy this one and shift it to that curve. Or even consider it's the same similar part here right now. It will take some time to copy. So better, this will be exact curve. You have to draw it here when you will sketch it for this one. It will be the similar curve in that case. And then the question is saying, hence or otherwise deduce the number of solutions of the equation cos 2x is equal to sin x between the region 0 to 20. So for x equal to 20 pi, first it's better if I will look for the 2 pi. Let's see between 2 pi, this is, for example, this is 2 pi. So how many times these curves intersect from 0 to 2 pi? 1 time, 2 times, and 3 times. Between 0 to 2 pi, the curve intersects 3 times. So I can say for 0 to 2 pi, for 2 pi, the number of solutions are, here if I will write the angle and here solutions. So I can say for 2 pi there are 3 solutions. So for 20 pi, how many solutions will be cross multiply? It can be x into 2 pi equals to 3 into 20. So x will be equal to, so sorry, for 2 pi there are 3 solutions. So for 20 pi it should be 20 pi. How many solutions will be? So that will be 3 into 20 pi over 2 pi. So that will give me 30. So there are 30 solutions. It means 30 possible solutions are. Now from 0 to 21 pi. For 1 pi, for each 1 pi, let's see how many solutions are for. For each 1 pi, you can see this 1 and 2 solutions. So after 20, 20 has 30 solutions. So for 21, there will be 32 solutions. That is end of this question. Now let's move to the next question, which is also a pretty simple question. Solutions based on entirely graphical or numerical methods are not acceptable. F of x is given, you have to solve the equation f dash x equals to 0. So first of all, we need to find the first derivative, f dash x. Use the power rule to 5 over 2 x 1 minus from the power minus 40 into 1 plus 0. So f dash x will be equal to 2 will cancel, 5x to the power 4 minus 40. So now I have to put f dash x equal to 0. If f dash x equals to 0, then 5x to the power 4 minus 40 will be equal to 0. And from here I can get 5x power 4 equals to 40. So x power 4 will be 40 over 5, which is 8. Take the fourth root on both sides. If I will take the fourth root of, let's take the fourth root of 8 will be 1.68. So that is equal to 1 point, x will be equal to 1.68. Now solve the equation f double dash x equals to 5. Now we are having first derivative. Let's take another derivative, double dash x, which will be equal to, now taking derivative of this one will be 5 into 4 x power 3 minus 0, that is 20 x power 3. Now if I will put it equal to, as it is given, f double dash x equals to 5, so what will be? It will be 20 x cube equals to 5. X cube will be equal to 5 over 20. Take the cube root on both sides. We will get x equals, let's take this cube root of 5 over 20. Give you 0.6299, which I can write to 0.630.